This is our last screencast on the properties of the real number system, and it culminates in simplifying expressions like this. So we use the associative, commutative, and distributive properties to simplify complicated expressions like this. Developing fluency in combining like terms is an essential skill needed throughout the rest of the entire course and in any study of algebra in the future. So we want to rewrite an expression like this. First, notice that we are adding on this product right here. Well, you've got 2 times this difference of 3x minus 1. Here we should use the distributive property. The 2 should be multiplied into the 3x and into the 1. And then the new expression would be negative 3x squared plus 4x minus 1 plus 2 times 3x is 6x minus 2 times 1 is 2. So notice we first use the distributive property to clear these parentheses. Once we've got this, we technically will use the commutative and associative properties to combine the like terms here. Negative 3x squared has no other like term here, so that's going to stay the same. And then we have plus 4x plus another 6x is a total of adding 10x. So those were 2 like terms. And if you subtract 1 and subtract 2 as well, that's equivalent to subtracting 3. This messy expression simplifies to just this expression here. And notice these are not like terms, so we can't combine it or clean it up any further. Let's do some more practice with this. Let's simplify this expression here. Notice we've got 3 times this difference and 5 times this difference. So let's first use the distributive property twice to get rid of these parentheses. Over here, you've got the 3 times the x and the 3 times the 7 would give you 3x and then minus, because it was subtraction here. The 3 times the 7 is 21. Plus, we've got 5 times the 2x is 10x. Minus, because we've got subtraction here, 5 times the 1 is 5. Now that you've cleared all the parentheses here, we can combine the like terms that we see that are left. We've got 3x, adding on 10 more x would give us a total of 13x. Remember, the variable part does not change when you combine like terms. You just combine the coefficients accordingly. And then we're also subtracting 21, and subtracting 5 more is the same thing as subtracting a total of 26. This expression is the same thing as the original expression, but it's much cleaner and simpler. And again, 13x minus 26 cannot be simplified any further because these are not like terms. So this is the simplest the expression can get. Let's try it again with this one. Here, notice we've got some more distributing. Let's distribute the negative 6 into this. We've got negative 6 times x is negative 6x. Negative 6 times 4 is negative 24, but remember you're subtracting it. So you're going to have minus negative 24, which would be the same thing as plus positive 24. Now for the back here, you can think of this in a few ways. One, we're subtracting this entire sum. So to subtract the entire sum, you need to subtract each of the parts. So we need to subtract 2 and then also subtract 3x. Or if you want to see this as distributing a number in, technically the subtraction of something is the same thing as plus the negative version of that something. And remember, taking the opposite of a sum is the same thing as multiplying it by negative 1. So really what's happening is we're distributing a negative 1 in here. And negative 1 times 2 would give you the minus 2, and negative 1 times 3x would give you the minus 3x. However you'd like to think about that is completely fine. Once you've done the distributing, then we can combine the like terms. You've got negative 6x minus an additional 3x puts you down at negative 9x. And we've got 24, take off 2 gives us, we've got 22. This expression is equivalent to this one, but it's much simpler. Let's now take a look at this one. In this case, we've got to be careful. What are we distributing in here into this sum, the x plus 4? Well, the key is to understand that technically we would need this as a sum. So what we kind of did right here with the negative 1 here is the same idea what we're going to do here. Minus 3 is the same thing as plus negative 3. We saw that on a previous screen. So this is 17 plus negative 3 times the quantity x plus 4. Subtracting 3 and adding negative 3 are exactly the same thing. Now that you've got this written as a sum, we are distributing a negative 3 into the x and into the 4. That would give us 17 we still have, plus negative 3 times the x is negative 3x, plus negative 3 times the 4 is negative 12. So once we rewrote this subtraction by 3 as addition by negative 3, we distributed in a negative 3. If you didn't want to look at it that way, you could technically think of this initially as distributing 3 in here, but you also would then be subtracting the sum that's left. So you would need to subtract each of the parts just like we did over here. No matter how you think about it, as long as you get the correct solution, that's fine. Now, once we get down to here, we then can combine like terms. There is no like term to negative 3x, so we'll start with that, negative 3x. And then we've got 17 plus a negative 12 gives us a total of plus 5. Negative 3x plus 5, that expression is equivalent to this expression, but this is simpler. We're now going to use the distributive property in a different way than what we just saw on the previous screen. Let's first take a look at this. Rewrite 1/2 times the sum 4x with 6 using the distributive property. So the 1/2 would multiply into the 4x and into the 6. Well, half of 4x is 2x, and half of 6 is 3. And this was addition, so it's 2x plus 3. This is how we use the distributive property on the previous screen, but now I want to look at a problem like this. We want to rewrite this fraction, 4x plus 6, that sum over 2, using the distributive property. Very often people look at this and say, I'm not sure how the distributive property applies, but technically multiplying by 1/2 is the same thing as dividing by 2. So this expression is exactly the same as this. So this is essentially the division form of the distributive property rather than the multiplication form. And notice when you distribute the half in here, you get 2x plus 3. So we should get the same thing down here, 2x plus 3. So you can think of it this way. We need to distribute this 2 into each of these division-wise. So the 2 needs to divide into the 4x, giving us 2x, and the 2 divides into the 6, giving us 3. So we have 2x plus 3. So in general, if you've got a sum divided by a number, the number in the bottom divides into each term of the sum. Here we have a bunch of examples. We want to simplify these fractions. We want to use the distributive property if necessary. So for some of these, the distributive property is needed. For some of them, you wouldn't use the distributive property. So the way you can tell, based on what we saw in the previous problem, is if you have a sum or a difference in the numerator, then we need to use the distributive property to have the denominator divided into each term of the numerator. So where do you see sums or differences? Well, there's no sum or difference up here. There's no sum or difference up here. There is a sum here, and there's a difference here. So these two are going to require the use of the distributive property. These two will not. So let's do these two first to solidify the idea of using the distributive property to simplify fractions. And then we'll go back to simplifying these, which is actually a function of the exponent laws. So over here, the negative 2 needs to divide into both the 6x and the 10. 6x divided by negative 2 is negative 3x, and we are subtracting here, so we've got minus, and then 10 divided by negative 2 is negative 5. And of course, people are not going to typically write minus negative 5, would simply write this as plus positive 5. So this is negative 3x plus positive 5. This expression is equivalent to this fraction. This is much simpler to work with. Down here, we have a sum in the top, so the 4 needs to divide into the 3x and into the 8. We are using the distributive property in the fraction form. Well, 4 doesn't go evenly into 3. So we're just going to write this as 3/4, and then of course we have still times the x. The 4 goes evenly into 8, and 8 divided by 4 is exactly 2. So while it didn't simplify this fraction as much as this fraction was simplified down to this is still a simplified version of this fraction here. Now over here, because there's not a sum or a difference in either of these numerators, the distributive property does not apply. Let's try this one actually first here. So over here, the 4 divided into the 3x and into the 8, there is no sum or difference here. So the 4 is not going to divide into the 3x and the 8. This is just 3x times 8. So this is a matter of dividing out common factors. We simply do the 8 divided by 4 would give us 2, and then we're left with 3x times 2 is 6x. So notice the 4 didn't divide into both of these things. It divided into one of them, and I had it divide into the 8 because 4 goes evenly into 8. Whereas when you have a sum over here, this 4 divides into both parts, i.e. we're using the distributive property here, we're not using the distributive property here. So this expression is just simply 6x. Let's simplify this one. 14 tenths is simply just 7 fifths because 2 goes evenly into both 14 and 10. And then you can expand this as 7xxy over 5xyy, and then divide out the common factors, for example, a pair of x's and one pair of y's. Or you could just look at this and say there's 2 x's up here, divided by 1x would leave you with 1x in the top. And here you've got 1 y in the top and 3 y's in the bottom. One of these y's would divide out with this y, leaving us with 2 y's in the bottom. However you want to do it, either way, we end up with 7x is left in the top and 5 times y squared is left in the bottom. So notice again, we did not do any sort of distributing here because there was no sum or difference in the top. So in summary, the distributive property is needed to simplify these two fractions because they have either a difference or a sum in the top, whereas the distributive property is not used to simplify these two fractions because there's neither a sum or a difference in either of these numerators.